In this video, we're going to talk about how to find the integral of an Euler exponential function, which is as follows. So, the integral of e to some placeholder u times the derivative of u with respect to x is equal to e to the u plus c. So, essentially, the integral of an Euler function is itself. Another way to look at it is e to something, okay, whatever that something is, whether it's x, 2x, whatever, as long as there's an x in there somewhere, times the derivative of whatever is in here with respect to x dx is equal to e to whatever that exponent is plus c. So that may sound a little bit abstract, so let's do an example. So let's say we have the following function here, f at x is equal to 6 times e to the 3x, and we're asked to find the integral f at x dx. Well, what we can do is we can define our placeholders, okay? So we can let our placeholder, we'll call it this box here, okay, this box is our placeholder, equal the exponent, okay? So 3x equals 3x. What that means is the derivative of that placeholder, d box by dx, is going to be equal to the derivative of this, which is just 3. So from this point on, we can now go on to arranging our integrals in a way that we can solve it. So let us write it as, so the integral of f at x dx is equal to the integral of 6 times e to the 3x dx. Okay, so what this dx means is that we're going to be integrating with respect to x. Now, of course, what we want is to have it in this form here, okay, because we want to integrate with respect to this placeholder here. So what we can do is we can write this here. Okay, so the integral of 6 times e to our placeholder dx. Okay, but as you can see, we have a problem now. We have this variable here, this placeholder, and we have a dx. Well, we don't want dx, we want d box, right? We want this. So what we can do is we can multiply this by this right here, this d box by dx. D box by dx. And what you can do is you can visualize these dx's canceling out. And so now it is in a good form to integrate. So the way we would write this is the integral, when we substitute our numbers back in, 6 to the e, or sorry, 6 times e to the 3x, okay, times d box by dx, which is 3, okay, times, or sorry, before I do that, one thing I want to point out is this. So as you can see here, it is, oh sorry, my bad, yes, we do want to multiply by 3, excuse me. Okay, so we multiply this by 3, okay? So now, as you can see here, and then we'll just put the dx here, right? Because we don't want to forget that, so the dx. Okay, so now I'm going to talk about my next point here. So this is now in this form here, okay? So here's d box by dx, there you go, and here is dx, here you go. The problem is though, this expression right here does not equal this expression right here, okay, because we have this extra 3. So what can we do to remedy that? Well, we just have to cancel out the 3 somehow, and we do that by multiplying this by 1 over 3. So then what we can do now is we can bring the 1 over 3 out of the integrand, 1 over 3 out of the integrand, okay, and that leaves us with 6 times e to the 3x times 3, okay, dx. Bring this one a bit closer. Okay, and now this is ideal. This is the perfect integrating form because this, okay, is equivalent. This entire term expression is equivalent to this expression, but also this integrand here is in this form here, which is what we want. So now we can go ahead and perform that integration without having to worry about this 3 here. Okay, and so when we integrate, that will give us 1 over 3 times 6, okay, times 6, and then as we know, the integral of e to the something is just itself, so we go e to the 3x. Of course, if we wanted to, we could have also pulled this 6 out of the integrand as well. That would have been a slightly better form too. Actually, let me just do that because that makes more sense. Because actually, this is not in this form quite yet. So let me do that. So 1 over 3 times 6 times e to the 3x times 3 dx. Okay, perfect. Now this integrand is in this form here, while also this expression still equals this expression here. Okay, so performing the integration, we get 6 over 3 times, okay, we don't have to worry about this 3 anymore, e to the 3x plus c, which just simplifies to 2e to the 3x plus c. And there's our answer.